Okay, this question might seem ominous. I'm starting with question 20. In question 20, what you want to do is you want to focus on the trigonometric identity. So we know that we're looking for, according to the question, it'd be nice if I knew what the question was. We're looking at cotan theta over 2. And so what we know about cotan theta over 2 is that it is the equivalent of 1 over tan theta over 2. By default, we also know that tan theta over 2 can be re-expressed using the trig identity where you have sine over cosine, right? So if I look at it this way, I'm going to use the square root of 1 minus cosine theta over 2 over the square root of 1 plus cosine theta over 2. So I'm using the half angle formulas for sine and cosine in this case. Okay, now you notice the fraction bar here, okay? And so we're first going to keep change flip, and this is going to become, in the next step, the square root of 1 plus cosine theta over 2 over the square root of 1 minus cosine theta over 2. Alright, we don't like radicals in the denominator, so we're going to multiply top and bottom by the square root of 1 minus cosine theta over 2 over the same thing, 1 minus cosine theta over 2. As if on cue. She knows that I'm teaching you, so she's got to start barking. You're going to start hearing her. Okay, when you multiply two different values, so I'm gonna bring you back to a little concept. If I have square root of 5, for example, times square root of 7, this becomes square root of 35, doesn't it? However, when you have the same value in the radical, so let's say I have square root of 5 times square root of 5, this actually becomes what's inside the radical, right? Because square root of 25 is 5. That's what happens here because both of these are identical, whereas the top are not. These are different. This is a plus and this is a negative. Let me not do that with that highlighter. Let's use maybe the green. Do you see what I'm saying? So these are different, these are the same. Okay, because of that, we apply the following rule. We are going to obtain the square root of 1 minus cosine squared theta, because this is like an a minus b, a plus b kind of situation in terms of the factors. So you end up with a squared minus b squared. And obviously the square root of 4 at the bottom here, which in this case, square root of 2 will eventually come out, and we can factor that. That eventually is going to cancel anyway, the top and the bottom. Okay, so I just multiplied them at this point. I haven't done anything with the radical yet. The bottom part, I end up with the square root. Now this time, the radical goes away because they are the same. So I end up with, in this case, 1 minus cosine theta, and I will end up with a 2. Okay. If you're with me so far, you will notice that square root of 4 is going to eventually turn to a 2. I'm going to be left with, in this case, the square root of sine squared. Before you get nervous about that. And this is square root of 4, which now becomes 2. Remember the identity that you have sine squared theta plus cosine squared theta equals 1? That's why I was able to do that, right? Because sine squared theta is equal to 1 minus cosine squared theta. Okay? This equal to or divided by 1 minus cosine theta over 2. Guess what we do again? Here's a fraction bar. You've got two fractions, so we're going to keep change flip. So we know now that the square root of sine squared theta, obviously that's going to give us the numerator of sine theta over 2, and this over 2 stays here, right? Over, or not over, but times, in this case, 2 over 1 minus cosine theta. If you remember, these two guys cancel out. And now you're left with sine theta over 1 minus cosine theta. And that, my friends, is number 20.